The chain rule. This is fundamental to any time we're taking a derivative in calculus because we've been working with polynomial functions, but typically we have much more detailed functions to work with. And shy of expanding something raised to the third or fourth power, we don't have another way to deal with what's called a composition function. So we'll start with what a composition function is, and we have it up here, h of x is equal to f of g of x, and you might have seen it written as h of x is equal to f o g, sort of this little O symbol right here, which means the same thing. You plug in x, sorry if we look at the picture, you take an x, you plug it into g. Output, you some y value. But this says take that value, plug it into f. Once I plug it into f, I now output a new y value. So this is what we mean by a composition function, where we're plugging x into something, getting an output, plugging it into another function, and getting a new output. So this is not commutative. We have to do one at a time. So for these composition functions, we have what's called an outer function, and we have what's called the inner function. The inner function is whatever it is you're going to do first. So looking at number 1, I'm first going to rewrite that. That is sort of the mathematician's way for writing the fact that we have sine of x, that whole thing has been squared. So what's the inside function? When I first enter x into this, what's the first thing that I'm going to do? And the first thing that I'm going to do is I'm going to take the sine. So g of x, which is the inner function, is your sine of x. And then it says, okay, great, what is the outer function? Well, the outer function is once you've plugged in x and you've gotten the sine, what do you do with that? So our f of x is going to be x squared because I square that number. So let's look at the next one. This is sine of x squared. So I'm going to rewrite it using the colors that I just used. So my inner function is going to be green. What's the first thing I do when I input my x? Well, that is I square it. After I square it, what is it I do to that number? I take the sine of it. So I've now identified my inner function is the x squared because that's the first thing I do to my x once I input my x. The second thing that I do is I take that and I take the sine of it. So my outer function is the sine of x. In number 3, I have e raised to the 3x. So of course, when I take my x and I first plug it in, the first thing that I'm going to do is I'm going to do 3 times x. That's going to be my inner function. Once I have that number, I'm going to take e raised to the 3x. So my inner function, g of x, is just 3x. My outer function is e raised to the power. So my outer function is e to the x. In our last one, we have an inner function and an outer function. So when I first input x, the first thing I do to it is I square it and I subtract 1. That's my inner function. Once I have this value, I'm going to take it and raise to the third power. That's my outer function. So my inner function, g of x, is x squared minus 1. And my outer function, what do I do to that, is cube it. So my f of x is x cubed. Part C. Part C is just working with compositions, and we're going to be using tables of values and graphs to do so. So in question number 1, the first thing I need to do is I need to take 2 and I plug it in to G. So the first thing I need to do is take G2 and plug it into G. So to do that, I'm going to find G, which is G. G is over here. And I'm going to plug in 2, and when I plug in 2, the output is the y value, which is 1. So at this point, I have f of 1. So now I need to input 1 into f. To do that, I take the 1 and I'm plugging it into f. When x is 1, my y value is 0. So this is equal to 0. Number 2. In number 2, I'm going to take 2 and I'm going to plug it in to f first. So I'm going to take my 2, plug it into f, which is right here, and that y value is 4. So now I know that that y value is 4, and I also have to take g of 4. So then I take my 4, I plug it into g, and the output of that is -1. So g of f of 2 is -1. Moving on to number 3. We now are going to take -4 and plug it in to g. So for this one, it's not in the graph. My graph only goes to -2, so I need to go to the table. So I go to the table, and when x is -4, g is 7. So g of -4 is going to be 7. Once I've outputted that, I need to take f of 7. So again, looking at my graph, x values do not go up to 7 on my graph. For f, it goes up to 3. So I need to use my table. So I'm going to take this value. Here's my x value. And now I want f of 7, which is 50. So f of g of -4 is 50. For number 4, we have g of f of 1/2. So first thing I'm going to do is I'm going to take 1/2 and plug it into f. I wouldn't look at my graph for that. I would try and look at my table. So when x is 1/2 or 0.5, I want f this time, and that is -0.5. And once I have that, I would like to take g of that value. So g of -1/2, I don't have that in my table, so I do kind of need to look at my graph now. And when I take g of -1/2, that is approximately 3.5. In number 5, I have g of f of 2.5. So from here, I'm going to take the 2.5 and I'm going to plug it into f. Again, that's on my table, and that output is 7. So now I'm going to take g of 7, and 7 is in my table. So I'm going to take that, plug it in here, and now I want g, which is 2.3. And that's composition from a table or a graph. Moving on to the next page. Now what we want to do is some calculus. So we want to find the derivative of a composition function. So what we're doing now is, this says, find the derivative of, and that is our composition function. This is asking us to do an exploration. We're not going to do the exploration. What we're going to do is we're going to rewrite each one, just like we did on the front, with an inside function and an outside function. And then I'm going to show you what the derivative is and see if we can figure out what the pattern is. So in number 1, we have h of x equals sine of x quantity squared. I'm going to rewrite that. My inside function is actually sine of x. When I plug in my x, that's the first thing I do is I take the sine of it. Once I have that value, then I square that number. So my inside function is sine. The outside function is something squared. So I'm going to write down what this derivative actually is. What I'm going to do is I'm going to get 2 times that same thing. I'm going to fill it in just a minute, and that's going to be raised to the first. So it's just like the power rule. I bring my exponent down, and now it is raised to the first power, 1 degree less. That was still the sine of x, but was in the parentheses. And now what I need to do is multiply by the derivative of that, and the derivative of sine of x is cosine of x. In the next one, my inside function is I square x first, And then the outside function is that I take the sine of that. So starting on the outside, the derivative of sine is going to be cosine, and it's cosine of the same thing, exactly what used to be there, which is x squared. Then I'm going to multiply by the derivative of the inside, and the derivative of the inside is 2x. And number 3, e raised to the 3x. The inside is the first thing I do to the x, which is multiply by 3. The outside is, then I take that number and I take e raised to that number. So I start with the derivative of the outside. And this one, we haven't talked about this yet, so we're not going to do this derivative. We're going to do that one next class. So number 3, we're going to do next class. Number 4, let's identify our inside. The inside, the first thing I do to x when I plug it in is I square it and subtract 1. Once I have done that and I found a value, I'm going to take it and raise it to the third power. So now to do the derivative, I'm going to start on the outside. I had something raised to the third power, which means now I'm going to have something raised to the second power, and I'm going to have taken the exponent out front and multiplied by 3. The inside stays exactly the same, x squared minus 1. Then I need to be sure and multiply by the derivative of the inside, which is 2x. Moving on to part B. So this is the actual function machine of what's happening with the chain rule. We're going to take our x and we're going to plug it into g, and we're going to output this g. Then we're going to have the derivative of the outside of the g, which was my inside. Then I'm going to multiply by the derivative of the inside. So that's what we have over here. The derivative of the outside of the inside times the derivative of the inside. Of course, f is the derivative of the outside, f prime. So now that we've done a few chain rules, we're going to look at the chain rule from a table of values. So in number 1, we're trying to find h prime of 4 if h is f of g of x. So the first thing I need to do is I need to rewrite my derivative. And again, f is the outside and g is the inside. I cannot plug any numbers in first. I must find the derivative using just x first. Then I'm going to go to the table and use some numbers. So when I take this derivative, it's going to be the derivative of the outside. I still plug in the same inside. And then I'm going to multiply by the derivative of the inside. So now let's put this in terms of what we're trying to find, which is h prime of 4. So then h prime of 4 is going to be f prime of, the inside stays the same, g of 4 times the derivative of g at 4. Now we can start moving to our table. So the very inside part is my g of 4. So I need to take that and plug that into my f prime. So first thing I need to do is find g prime of 4. So here's my g prime. Sorry, not g prime, g. Here's my g. And when x is 4, I get 3. So I'm going to plug in a 3 right there. And now I'm going to have f prime of 3. Let's go ahead and find g prime of 4. So g prime of 4, I'm looking at g prime, and I want when x is 4, and that value is 1 times 1. So now I just need to evaluate f prime of 3. So I look at my table of values, I look at f prime, I want when x is 3, and that value is 2. So I would write h prime of 4 is equal to 2. For the next one, we're now finding k prime of 4, and k is g of f of x. So the first thing I'm going to do is I'm going to rewrite that with the outside and the inside. So g of My inside is now f. So when I take the derivative, it's the derivative of the outside. I still keep the same inside, which is my f of x, and then I multiply by the derivative of the inside, which is f. So let's plug our numbers in. We now have g prime, and we're taking f at 4, and we're multiplying by the derivative of f at 4. So again, I'm going to start with the inside, and I'm going to figure out what f of 4 is. So I come back over to my table, and I look at f of 4. So here's f, here's 4, and that value is 4. And then I'm going to multiply by f prime of 4. So f prime is right here, 4 is here, and f prime of 4 is 3. Now I need to go back to my table and look up g prime of 4. So g prime is right here, 4 is right here, and g prime of 4 is 1. So I have 1 times 3, which is just 3. So now I know that k prime of 4 is going to be 3. Going on to illustrating the chain rule algebraically, it says go through the algebraic steps to show that sine squared of x is equal to sine of 2x. Now immediately this sine of 2x right here kind of like makes the hairs on the back of my neck stand up, because this is a sine of 2x, whereas over here I was only talking about x, which means I really need to know one of my trig rules that of course we all have memorized. I'll write it down for us in case we don't remember. 2 sine of x cosine of x is equal to sine of 2x. And I know we're going to need that rule because I can't change an x into a 2x unless I use one of my trig identities. So let's go ahead and work on finding this derivative. I need to find my outside and I need to find my inside. So when I first take x and plug it in here, what am I going to do to that first is I'm going to take the sine of it. So sine of x goes on the inside. And once I've gotten this value of sine of x, I'm then going to square it. So when I take the derivative of this, I'm going to take the derivative of the outside first. So here's my d dx. That means an operation. Take the derivative with respect to x. Start by taking the derivative of the outside. I multiply by my exponent. My exponent is now subtracted by 1. And my inside stays the inside, sine of x. And then I multiply by the derivative of the inside, which is cosine of x. So I have this 2 sine of x cosine of x. And luckily, we remembered our rule over here, and 2 sine of x cosine of x is actually the same as sine of 2x. So that is exactly the same as sine of 2x. And we have now shown that the derivative of sine squared of x is equal to sine of 2x. Hope you have a nice evening and bring any questions you have to class.